What's up, Sci-Fam? It's your boy Nickel. Today we're going to learn about H2O, the molecule. So our page is going to be chocked full of information related to the molecule known as water. So we'll go through several different vocabulary terms, and we'll talk about how water flows through the water cycle in different ways, and also some of the properties of the water molecule. So let's start by looking at water as a chemical, as a molecule. So we have H2O. It's a very, very common molecular name, or just understanding that it's made out of two different elements, H and O. Well, H stands for hydrogen, and O stands for oxygen. The 2 that is a subscript here, H2O, the 2 actually goes with the H, meaning that there's 2 H's and 1 O. So the 2 relates to the atom of hydrogen. So a water molecule has 2 hydrogen atoms that are bonded with 1 oxygen atom. So when we have both of these combined, since we have 2 hydrogens, we use the prefix di, so we're going to say dihydrogen. And we only have 1 oxygen, so we say mono for oxygen, monoxide. So dihydrogen monoxide is the chemical name or the molecular name for, and let's write molecule name, the name of the molecule. Kind of like how CO2 is carbon dioxide because there's 2 oxygens there. The molecule name for water is dihydrogen monoxide, but the common name that we use for H2O is just simply water. So the common name is water, the molecule name is dihydrogen monoxide because there are 2 hydrogen atoms fused with 1 oxygen atom. And so if we were to actually draw this, and it'd be good for you to draw it there on your science notebook page, is that we'll have 1 molecule that's bonded to these other 2 here. And actually I want to do this a little bit differently because these ones are much smaller in size than the top one here. So this top, the molecule here at the top is our oxygen. Or we could just say O. And these down here are our hydrogens, and we could just say H. Well, the oxygen is such a big atom here that it's actually going to want to steal the electrons from hydrogen. And the electrons are usually sitting here next to hydrogen. But since oxygen wants those electrons, it actually tries to steal them from hydrogen. But instead what happens is that these electrons, they don't directly go to oxygen, but they kind of hover closer to oxygen. And oxygen already has electrons here as part of its atomic structure. So it's trying to get these 2 extra hydrogen, or these 2 extra electrons from hydrogen, which means that it ends up creating an interesting situation with this molecule. And that most of the molecule, this top part, is more negative. And since these electrons got pulled from the hydrogens, these hydrogens aren't as negative, and so they're more of a positive charged molecule. So what we find is in a water molecule that has this type of shape, it's like this triangular type of shape, it has a negative side of it and a positive side of it, kind of like a battery or kind of like a magnet. So because of that structure right there, we call water a polar molecule. Let me get a different color here. So water is known as a polar molecule because it has different poles. It has a negative pole and a positive pole. It has one side that is more positive. There we go. Water is a polar molecule, which means it has one side that's more positive and one side that is more negative. And we put the negative sign there. So what this means then is it actually behaves like a magnet. So when water is around other water molecules, it actually wants to pair up with those water molecules. And when it does, this more positive side of the water molecule is going to want to pair up with a more negative side of another water molecule. So we end up seeing if that's another water molecule, they end up stacking in this fashion. So they actually are going to orient themselves in a very specific way because they're a polar molecule. One side is positive and one is negative. One side is more negative. But there's some more other unique attributes about water. So let's draw water in its 3 different states. We'll draw it here as a solid first, then we'll draw it as a liquid, and finally we'll draw it as a gas. So it's the 3 states, it's physical states where it's a solid, liquid, or gas. Now, I'll just use a circle to show a water molecule. And obviously, like we know, a water molecule is made out of 3 atoms, not just this one. So the circle represents the molecule. And when it's a solid, it means that all of these molecules are actually stacked next to each other. If we look at how those are stacked, and you don't need to draw this part here in your notebook, but what we would find is that each of these water molecules are actually stacked so that one of the positive sides is next to a negative side, and they stack in a way that are going to be like magnets would stack, where it's positive attracts negative, negative attracts positive. So they have to be oriented in a certain way when water is in a solid type shape. Something that's interesting about water, or anything that's a solid, is that it actually has some type of vibrational frequency, even as a solid. These molecules are still vibrating. They're just vibrating very, very slow. So that's what it would look like if we were to stack a bunch of water molecules next to each other in a solid. Now, if we were to actually add heat to this, we would say that that solid is going to go through a process of melting. So the common name for water when it's a solid is ice. When it melts, then it turns into a liquid, and we just call that water. So water is the common name of the molecule, but also the common name of what H2O is when it's in its liquid state. And when it's a liquid, it's going to take up the shape of the container. So it's going to flow. If this box was filled with water, I would end up having the water molecules wouldn't float. In the air here, they would all sit at the bottom, and it would take up the shape of the container. Now, just like the first water molecules had some vibrational frequency, these also have a vibrational frequency. They have more energy in them. So therefore, we're going to draw some lines here to show that these molecules are actually moving around on their own because they have some thermal energy in them. Obviously, you have to heat up ice to turn it into water, so those molecules have more energy. Now, if we take that liquid water and we add even more heat, then we can turn the water molecules into gas, and now they're going to have tons of energy. So they're going to be bouncing around in this box if they were a gas. So I'm going to draw these little lines along with the little molecules to show that they're bouncing all over the place. All right. Now this we typically call steam, but steam is a gas, or we might even call this vapor, like water vapor or steam. So when it's a liquid and we add heat to it and we get the steam, we call this evaporation. So if you've ever boiled water on the stove, you saw that water evaporate when you saw the steam. Now, if we were to cool down and if we were to remove heat energy from the gas, it would turn back into a liquid. It would turn back into water. Now, this is what happens when you have a glass of water and you have it sitting on the counter, and all of a sudden water starts to form on the outside of the glass. And what happened is that there's water in the atmosphere as a gas. It cooled down because of your cool cup of water, which is colder than the air. And so therefore the water that was in the air actually condenses onto the glass, on the outside of the glass. The water in the glass didn't leave the glass and move to the outside. The air around it just turned from gas into liquid. So we call this process condensation. Now we can go from gas to a liquid. And if we do, we go through this process, we call that condensation. But if we go from a liquid into a solid, this one we call freezing. This is what we do when we add liquid water into an ice tray. We put it in the freezer to cool it down, which means we're going to remove some of that heat energy, and it turns into a solid. All right. So these are all important terms that you're most likely familiar with: melting, evaporation, condensation, and freezing. And it shows that it's when water changes state from a solid to a liquid to a gas. But there is some other phases that we're going to discuss here at the bottom. But before we do, something that's a really interesting fun fact here, I'm even going to put a star here, because water, the molecule of water, is the only substance on Earth. Not only on Earth, but it's the only one that is stable in all 3 states. So it's the only type of molecule on our Earth that's stable as a solid, liquid, and a gas here on planet Earth for a substantial amount of time, meaning it's stable. It can stay as a solid, it can stay as a liquid, and it can stay as a gas. Now we find solid water on our planet as ice and snow. We find liquid water in our rivers, streams, and groundwater, and we find gas or vapor water in our atmosphere. So There's some other ways, though, that water can flow through the water cycle, and it's important to understand these terms, or at least to know how these terms relate to water and relate to this process of the fact that it moves in a cycle on our planet, and it moves from one region or one reservoir into another type of reservoir. And I don't mean like a lake reservoir, but like the atmosphere could be called a reservoir for water because it holds vapor water. So the first term that we're going to define is precipitation. Precipitation is any water that falls to the earth or to the ground from our atmosphere. So it was a gas in the atmosphere, or maybe it was in a cloud in the atmosphere, and then it gets heavy enough, it accumulates enough water molecules in the liquid form that it then falls through the atmosphere. And if it falls and it cools in that process, or if it cools in the cloud, then it might fall as snow or sleet or hail. The next term that we're going to define is one known as transpiration. Now, this is what plants do instead of sweating. And a plant leaf, if we could zoom in on a plant leaf here, we would find that there are some plant cells that actually have these little tiny openings, and these things can open and close, and when they do, they release different gases. So they release oxygen, for example, but when they do, they also lose some water out of these holes. So the water's in the ground, but since these areas are like holes to open up, it kind of sucks the water up the plant, and then it leaves the plant. So this is the process known as transpiration. And if we were to define it simply, it would just be evaporation of water from plants. So it travels up the stem to the leaves, and then it leaves the leaf as a gas. Next is a term known as infiltration. So you infiltrate something, you enter something. Infiltration in terms of water in the water cycle is when water sinks or is going to get into the ground. So it sinks into the ground or beneath the ground. So if the ground is dry, then the ground can absorb that water, and if the water goes into the ground, we'd say the water infiltrated into the ground. Next up is if the ground is completely filled with water already and water falls on it, then we have something known as runoff. And runoff is just when water flows over the ground. So technically we could say a river is an example of runoff, where the water can't go into the ground because below a river it's already, the soil is saturated with water. It's filled with water already, so the water can't go into the ground, so it goes across the ground. And when it does go across the ground, it's governed by gravity. Gravity is going to force that water when it travels over the ground to go downhill. The last term here is not specifically about plants or animals, but about both. And this is a process known as absorption. So when we drink water, we absorb the water into our body. When plants take up water, they absorb it into their quote-unquote bodies as well. So absorption is when plants and animals take water into the cells of their tissues. So our cells need water in order to go through the cellular processes. So we have to drink water, plants have to drink water as well. And when we do drink water, it doesn't just leave us immediately. A lot of it goes into our cells, and that's the process known as absorption. So we can use these vocabulary to understand the water cycle and to know where the water is going when we can't see it change from a liquid into a gas. We also have to understand that water is a unique molecule. It's a polar molecule, so it has unique properties to it. And it's the only substance on Earth that's actually stable in all three states. So now you know more about H2O, dihydrogen monoxide.